Hey 11th, today we're introducing something called Selections, which is exercise 10C on page 377 of your textbook. Now, over the last couple of lessons, we learned about how different counting methods can be applied, or rather, what counting methods are and how we apply them to find the number of possibilities available. Now, in the last lesson, we looked at permutations, and permutations being where order does matter. So the example I provided was something like a bike lock, where the order of, let's say, 1116 is obviously going to mount a different result from 6111, despite the numbers being the same. Well, today we're looking at situations where what if the order does not matter, right? So if the order does not matter, of course, we're going to have a different formula. And the reason being is because if, for example, if I go back to the bike lock, 1116 is the same as 6111. Of course, the bike locks don't work like that, but let's say it does in this particular case. If that's the situation, then the number of possibilities is going to be significantly less than before because, well, there's going to be an overlap, and so we don't count those twice. So instead of using NPR or N, obviously P being permutations, we're going to use C for combinations. So NCR. Just a note, selections and combinations is a different name for the same thing. We still use the same variables for R being size and N being the number of objects, but we use NCR when we know that the order doesn't matter. In general, the number of combinations of N objects in group size of R, so the same thing, except our formula is NCR equals to N factorial over R factorial times by N minus R factorial. You might notice it's the same as if I was to write out not N factorial, my apologies, I mean NPR, which is the formula from last lesson, divided by R factorial. Same thing, but I'd recommend you just write down or memorize NCR, pretty straightforward. Just also note that this alternative notation, your calculator may provide it as bracket N over R without the line. It's just a different type of notation. If you write it out as NCR, that's fine as well. So the example that I'm going to provide is about flavors of ice cream. Of course, if we have, for example, chocolate and vanilla as a double scoops option, it's going to be the same as vanilla and chocolate, well, at least I'd imagine in most situations. So the question in this situation asks, if there are 4 flavors of ice cream available, how many double scoop selections are possible if 2 different flavors must be used? Now, I'm going to go ahead and provide my own flavors of ice cream just for this question. I'm going to go ahead and say vanilla, chocolate, strawberry, and I'm trying to think of one more. Let's use caramel because that's the only thing I can think of right now. Sweet, I got those 4 flavors. So what combinations do I have? Well, I've got vanilla chocolate, vanilla strawberry, and vanilla caramel. Pretty straightforward. I'm going to go ahead and write caramel as CA. I've also got chocolate strawberry and chocolate caramel. And finally, I've got strawberry and caramel. Weird combination, but theoretically, those are the 6 possible situations in which I can get those options. Now, because the order doesn't matter, remember that vanilla chocolate is the same as chocolate vanilla, so I can't write chocolate vanilla again and count it as a second option. And so in total, we have 6 flavors available. 6 possibilities available under these circumstances. Now, if we were to use the formula, it'd be the same thing, except we're going to go ahead and use the formula, of course. Now, we know that the number of flavors is 4, so n equals to 4, and we know the group size is 2. And so we use the formula. We can write it as either 4-2, or we can write it as 4C2, which gives us 4 factorial over 2 factorial times by 4 minus 2 factorial. You can either put that in the calculator or solve it yourself. Remember, factorial is just a multiplication of the numbers going down. So we end up with a value of 6. Same thing. Here's what happens when we have to apply the addition or multiplication principle in such a method. So for this question, a team of 3 boys and 3 girls is to be chosen from a group of 8 boys and 5 girls. How many different teams are possible? Now the key part of this is and. Remember, and means this and that, which means the multiplication principle. And therefore, I'm going to separate the boys and the girls and then calculate the counting method, apply the counting method and calculate the number of possibilities from there. So if I focus on the boys, I know that for the boys that there is a a total number of 8 boys, which means of course n equals to 8. And I also know that the group size is 3 because there are 3 boys that we're choosing, so it's r equals to 3. From there, I'm going to go ahead and write 8C3, sorry. You can use the calculator or solve it by hand, once again, entirely up to you, and you end up with a value of 56. For girls, same principle applies. I'm going to go ahead and try to find the counting method. So n equals to 5, because there are 5 girls to choose from, and there are 3 girls that we are choosing, and so therefore n equals to 5, r equals to 3. Apply the same formula, except instead of 8, we're writing 5C3, which gives us a value of 10. Now, once again, like I mentioned earlier, we're applying the multiplication principle, because we're saying choosing 3 boys, from 8 boys, and choosing 3 girls from 5 girls. So we multiply them together, and I get 8C3 times by 5C3, which is just 56 times by 10, which gives us a final answer of 560. A little bit of a weird type of question to wrap your head around, but generally the structure remains similar. Now, there's one more note that I would like you guys to take account of when it comes to working with combinations. So the following is useful when counting all combinations of any size from a group of n objects, where we've got the formula where for n objects, remember n could be any number, we know that nc0 plus nc1 plus n all the way up to ncn equals to 2 to the power of n. 2 to the power of n. So just keep that formula in mind or write it down at the top of your page. The example I provided we have here where Nick is making an invitation list for his party and has 7 friends to choose from. If you may choose to invite any number of friends, obviously excluding 0 because that's not inviting anyone and that's just sad, how many possible party lists exist? Now we have to assume he invites at least 1 person to his party. So from here, it gets a bit confusing because we have to try and calculate what is how many different options are there if he chooses 6 people? What if he chooses 7 people? Or 8, not 8, sorry, there's only 7 people, or 3, right? So because we're using the term or, working with the addition principle, and therefore we have to think that we add the values together once we find them. But first off, we actually have to assume, well, let's say, how do I find when there's only 1 person on the list? Well, how many different possibilities are there? You can tell me off the bat, of course, there are 7 people. So if he's only choosing 1, there's only 7 options. But if I'm going to write it mathematically in this form, I can write, well, we know that n always equals to 7. And that value of r changes. So if r equals to 1, then we have 7c1. If r equals to 2, then 7c2. So this one right here would mean if I've got 7 people to pick from, and I'm selecting 2 people, how many possibilities are there? Now there is a function in your calculator to solve, for example, 7c2 without having to type all the factorials out, but I'll discuss that another day. I'm going to go ahead and continue. We got r equals to 3. We're selecting 3 people now. I equals to 4, and you're going to see that I'm going to keep going all the way up until we end up with 7c7. So r equals 6 gives us 7c6. I equals 7 gives me 7c7. Now, like I mentioned earlier, we're going to count up all these possible party lists because we're saying it could be 1 person, could be 2 person, or 3 person, etc., etc. So we add them all together. Now, you could go ahead and add them all up individually by finding the value of each one and then, well, adding them together. Or you can apply your understanding of the last formula that we just mentioned up here. So if nc0, now n obviously is 7 in this situation, 7c0 plus 7c1 plus all the way up to 7c7 equals to 2 to the power of, and instead of writing n, we're writing 7 because n equals 7. Well, then that would give us the answer, except we did not include nc0. We didn't include nc0 because nc0 would imply, well, there's no people to invite, and we specified earlier that we're not using 7c0. So what we can do is we can take away 7c0. Now that gives you 2 to the power of 7 minus 1, which ultimately nets you 127 possibilities. So there's a couple of shortcuts you can use, or you can just type in the calculator to solve it. Hopefully that makes sense. It's a little bit more of a complex topic than than our permutations, but best of luck and let me know if you have any questions.